This project explores the application of AI in the field of structural engineering. Structural engineering is a subject applicable in a variety of engineerings, like construction industry, mechanical engineering, aeronautical engineering, and oil and gas sector. The application of AI can reduce the time consumed in day-to-day structural designing with reduced effort. Furthermore, presumably the accuracy of AI predictions will be very high, as the relationship between the input variables and the output variables is mostly linear in nature. Through this project, the accuracy will also be explored. The application of AI in the field of structural engineering is vast but yet remains unexplored. The application of AI can reduce the time consumed in day-to-day structural calculations, as the relationship between the input variables and the output variable is mostly linear in nature. However, the input variables are changing every time a new structure is designed. This is a time-consuming aspect of structural engineering. This can be phenomenally reduced if AI can intervene and suggest structural sizes at an initial estimation level. AI for a single element will be a simpler task, but then it is also a simple task using computer program. The true benefit of AI in structural engineering would be exhibited when we can find preliminary size of a structural member working together in a structural system. One such structural system which is explored in this project is pre-engineered building system. Pre-engineered building systems are composed of tapered eye sections, where the main frame is the main force resisting system, and the design of this main frame is most time consuming and critical part of designing the entire building system. Pre-engineered building are special type of single-story frame structural systems used for large spans. These building systems are used for various types of structures like industrial buildings, warehouses, commercial complexes, showrooms, aircraft hangars, warehouses, factories and gymnasiums. Most PEB building systems are supplied by manufacturers on design-build basis, meaning that the manufacturer designs and supplies this building. This can be a tedious task if one has to design buildings for potential clients on daily basis for price estimates. Structural design of a building implies finding an optimal structural design that shall achieve a balance between the following requirements: strength, serviceability, and economy. This is known as optimal design. AI can be used to predict member sizes very quickly, hence building weights and cost estimates rapidly. This will be very effective practical solution and solving a real problem where the design and cost estimates can be prepared within minutes. In this project, a machine learning algorithm is produced using polynomial regression for prediction. An 80% dataset is used for training and 20% dataset is being used for testing. After the completion of the project, it was realized that an R2 score of 86 was achieved. A dataset of 50 to 80 pre-engineered buildings with optimized design was produced. This was utilized in a polynomial regression model that produced our AI model. The results deduced by our AI was then compared in StatPro to see and realize the efficiency of our AI model. The dataset eventually had 76 various PEB frame designs. Certain parameters were fixed for this small project. All steel was ASTM A36. The dimensional capacity for this algorithm was 20 feet to 100 feet span. Base spacing was 20 to 26 feet. Eave height 10 to 30 feet with a roof slope of 1:10. Roof live load 12 PSF as per American Society of Civil Engineering. Dead load 2 PSF and wind load was 90 miles per hour. And wind load characteristics as per ASC 7 were for 90 miles per hour exposure category B, and a building classification too. The AI gave us certain estimates for our test cases. 2 test cases are being presented in this presentation. The dimensions given by AI model were then tested in StatPro FEA software. It was realized that the output given by our machine learning model were excellent. Through this project, it was concluded that a simple machine learning code has produced excellent results by estimating PEB frame sizes within seconds. This hence shows that the application of AI in structural engineering has a huge potential. As far as initial sizing of structural members are concerned, even a simple polynomial regression model has proven to be very efficient. However, a sound data set for machine learning models is important. The future seems very bright for artificial intelligence in structural engineering.